Hello everyone. This video is about homework 2, section 2.5 and section 2.6. So for the first question, we're going to use the intermediate value theorem. So this one looks a little bit different from the intermediate value theorem because IVT is talking about that for a continuous function. Second, a continuous function is defined on a closed interval. And the third condition is they have different signs. Suppose one is less than 0. So this part means if one is positive, the other one must be negative. If one is negative, then the other one must be positive. And each of them cannot be 0. It's non-zero. It's straightly less than 0. So these three conditions is IVT. And then the conclusion is there must be, this notation means exist, and this notation means, this one means C is from A to B. In other words, C is greater than or equal to A, less than or equal to B. So this notation just means C belongs to this one. And the conclusion of IVT is there exists a C. C is a special point. C is from A to B, such that f of C is 0. So this is the IVT. And let's see how can we use this IVT for question number 1. Question number 1, the first condition, continuous function, is satisfied. And the closed interval is satisfied. But the third condition is not satisfied because we only know f of A is less than A, f of B is greater than B. So we can generate a new function and call the new function, suppose g of x, which is f of x minus x. Because the f of x is continuous function, x is a continuous function. This one is just y is equal to x. The summation of two continuous functions, g of x, is also continuous. And also, g of x is also continuous, defined on a closed interval, because this is a to b. This can also be defined on a to b. And the third condition, let's check the third condition that, this is the third condition. So this time g of A is equal to f of A minus A. And the g of B is equal to f of B minus B. And what about f of A minus A? We know from this condition, f of A minus A must be negative, and f of B from this condition must be positive. So actually the third condition are satisfied for the new function. Then we can just use the IVT. Then the conclusion is exist C is from A to B such that f of C is 0. That means g of C is 0. So g of C is 0. That just means, because this is g of x, so g of C is f of C minus C, that is 0. So you can see f of x is equal to C. That is right here. Then we're done. And similar for the second problem, we still use the IVT. So for this one, you can just move this side to the other side. And then this function is just 2x minus 1 minus sine c squared plus pi over 4. And we are trying to show this one is equal to that one. In other words, we are trying to show the left side minus the right side is 0. So in other words, we are trying to show this f of x is 0. So similar to the last question, we check the two boundary points. So let's see, for this function, plug in x is equal to 0. So f of 0 is something, and then you have to check if it is positive or negative. Then similar, we check f of the other part, f of pi over 2. So you check f of pi over 2 is positive or negative. Then if f of pi over 2 is positive and f of 0 is negative, or the other way around, as long as they have different signs, then we can just use the conclusion of the IVT. That means there must exist a number C from this interval such that f of C is 0. That means the left side and the right side, they are equal to each other. So you can see the basic idea is pretty similar to each other, just that this is an application of the IVT. And then number 3. So number 3 is this, you may see a similar question in the exam, because this question is copied from one of the passed exam 1. So for this one, the function is continuous. For this one, we don't have to use IVT because this is a different question. So for the function to be continuous, we have 3 conditions to check. And so the function is continuous on this negative infinity to positive infinity. In other words, the function is continuous on negative infinity to 2 and 2 to infinity. So that means you have to check the condition. That means the limiting value exists. So you have to check if the left side limit and the right side limit, they are equal to each other. So the left side limit 2 to negative, because in this function you can see the 2 is a special point. If x is less than 2, this is a continuous function. If x is greater than 2, this is also a continuous function. So you don't have to check these 2 intervals because we know it must be continuous based on the function equation. So you have the only point you have to check is what about this part? Because this part, union this part is just the whole part. So we know this is true, this is true. You have only to check this one. If we want to check the function is continuous at this point, you have to check the limiting value exists. So that's what I'm doing here. Left side limiting value is just a limit x approaches to negative. And then the left side is cx squared plus 2x. And similar, the other side, 2 plus f of x, is limit x approaches 2 plus x cubed minus cx. Okay, so we know you can just plug in c is 2 minus because this one is not 0 divided by 0. It's just it's safe. You can to just plug in x is equal to 2. Then you have something like, for example, when you plug it in, then you have 4c plus 4. This is the left side value. And then similar, we have another one. We know they must be equal to each other. So you can have a equation to solve for the value of c. Just use the left side and the right side, they are equal to each other. Then we are done because the question is just asking for the value of c. And they are pretty straightforward. And I want to talk about a little bit about this one. I noticed some students ask me, when limit x approaches infinity, why arctangent of x is pi over 2? Why? So there are many different ways. One way is just normally what I use is because I remember the function graph of this one. Arctangent is a function that has 2 horizontal lines, and the corresponding 2 horizontal line is just 2, pi over 2, and the negative pi over 2. So you can see positive infinity is just the pi over 2, and excuse me, this should be negative infinity because okay, negative infinity, the other one, limit x approaches positive infinity, arctangent of x is just a positive pi over 2. So one is negative, the other is positive, because you can see when x approaches positive infinity as pi over 2, the other direction, negative infinity, it is negative pi over 2 from the function graph. And the second way, you remember arctangent is the tangent inverse of x. They're the same thing. Arctangent just means the inverse function of tangent x. So we know the tangent x. So the question is actually asking, what is the angle theta such that, because the question is arctangent infinity is pi, what is the theta? So that means what is the value of theta such that tangent theta is infinity in the fixed domain from negative pi over 2 to positive pi over 2. So for the tangent theta, we know that theta is just a pi over 2 plus pi, n pi. But because the domain must be from negative pi over 2 to positive pi over 2, so we know it is just a pi over 2. The third one, we know that tangent of x is just this is the function graph tangent of x, which is negative pi over 2 and the positive pi over 2. So in the corresponding fixed domain, the infinity, when x approaches infinity, So from this function graph, you can see for the inverse function arctangent of x, this is looking for the value of theta, which is pi over 2, because when x is pi over 2, the corresponding function value tangent of x is infinity. So the arctangent of x is just pi over 2. If it is negative infinity, then this is the other direction. So this is the rest of the part is not that difficult. And the homework is due tomorrow, 11:59 p.m. And feel free to let me know if you have any questions. Thank you.